ever stopped to think which country has the biggest military helicopters in the world? The United States or Russia? In this video, we're going to look at how these two powers stack up, and by the end, you'll make that call yourself. Drop your answer in the comments. Let's get into it. 3 British Chinooks sat wrapped in the hold of a container ship in May 1982, packed for a war they hadn't fought yet. Then an Argentine Exocet missile found the Atlantic conveyor, and 3 of those machines went to the bottom of the South Atlantic with it. One Chinook, Bravo November, was airborne at the moment of impact, landed on HMS Hermes, and became the only heavy-lift helicopter the British had left in the entire theater. The maintenance crew ran the numbers. 2 days of parts, maybe 3. They were wrong by 80 days, without manuals, without spares, with a crew that slept next to the machine because there was no margin for delay. Bravo November moved troops, artillery, and supplies across terrain that no other aircraft could reach, doing the work of 3 Sea Kings on every sortie. That's not a specification. That's what happens when the people keeping a machine alive refuse to let it stop. In 1961, a Soviet helicopter flew level at 300 kilometers per hour. That number doesn't sound remarkable until you understand what the engineering community believed at the time, that rotary wing aircraft had a hard physical ceiling well below that speed, and nobody was close to breaking it. The Mi-6 broke it by cheating in the most honest way possible. Engineers bolted fixed wings onto the fuselage, wings that generated 20% of total lift during cruise flight, offloading the main rotor enough to push past what pure helicopter design allowed. It was simultaneously a helicopter and a fixed-wing aircraft that couldn't take off without the rotor. Simple solution, extraordinary consequences. After Chernobyl in April 1986, Mi-6s flew direct passes over the exposed reactor core, dumping extinguishing material into a situation that had no safe approach. Several of those airframes absorbed so much radiation during those missions that decontamination was declared impossible. They were buried where they stood, engines still inside, blades still attached. The Mi-6 didn't just go fast. It went to the places that consumed the machine entirely. Every Super Stallion returning from Afghanistan or Iraq carried an average of 150 pounds of sand distributed through its interior, not dust. Sand, packed into avionics bays, hydraulic lines, rotor assemblies, every system that needed clean air to function. That detail came out in a congressional hearing in 2003, stated plainly, with no particular alarm in the room. That's what changes everything about how you read what came next. By 2018, the Marine Corps had a congressionally mandated fleet of 200 Super Stallions. There were 143 left in inventory. Of those, only 37% were flyable on any given day, meaning on most mornings, fewer than 53 of the most capable heavy-lift helicopters in the Western world were ready to move. Someone reviewed that number every day and signed off on it, because there was no alternative ready, and the mission didn't stop. The Marines who strapped into those aircraft knew exactly what the readiness report said. They flew anyway. The Super Stallion isn't a helicopter that aged badly. It's a helicopter that was asked for too much, for too long, and kept answering. Eastern Siberia has no roads to most of the places that have oil underneath them. No railways. No prepared surfaces, just frozen ground, distance, and equipment that weighs 15 tons and needs to be placed with precision on a platform that isn't stable. That's the problem the Mi-10 was built to solve, and the solution was stranger than the problem. Engineers took the Mi-6's engines, transmission, and rotor system, stripped away the conventional fuselage, and mounted everything on 4 tall stilt legs, leaving the belly of the aircraft open to carry massive loads suspended underneath. Then they added a second cockpit made of glass, positioned at the bottom of the airframe. facing straight down. The operator lay face forward, looking directly at the ground, guiding loads centimeter by centimeter onto surfaces no crane could reach. The Soviet State Institute for Civil Aviation calculated that the Mi-10K was 5 times cheaper than any alternative for construction in inaccessible terrain. Not marginally cheaper, half the cost again. The technicians working those Siberian drilling platforms arrived by Mi-10, were resupplied by Mi-10, and left by Mi-10. The helicopter wasn't supporting that operation. It was the only reason the operation existed. Before it was the most capable special operations helicopter in the American inventory, it was a search and rescue machine flying into North Vietnamese air defenses to pull down pilots out of places nobody else would go. That was the HH-53, the Super Jolly Green Giant. What came after wasn't an upgrade. It was a rebuild so deep the aircraft got a new designation, a new identity, and a new mission. Terrain-following radar, forward-looking infrared. Precision navigation that could thread a formation through a desert at low altitude in total darkness without being detected. On the night of January 17, 1991, while the world would later celebrate the Apache AH-64 as the weapon that fired the first shots of the Gulf War, it was Pave Lows that led Task Force Normandy through the Iraqi desert, because they were the only aircraft with navigation precise enough to find the target. That detail didn't make the headlines. It rarely did. In September 2008, 3 days before the last operational Railsholm Pavlo was scheduled to fly to its permanent display at Hill Air Force Base, a ship was endangered by Hurricane Ike in the Gulf of Mexico. The crew launched into the storm. The Pave Low didn't want to stop. Nobody in the chain of command told it to. In 2001, a Russian Mi-26 flew into Afghanistan, rigged a sling load beneath its belly, and carried a U.S. Army CH-47 Chinook back to Kabul. One helicopter lifting another helicopter. The Mi-26 weighed more with the Chinook underneath it than the Chinook weighed at maximum payload. That's not a comparison designed to make a point. It's just what the numbers produce when you put them next to each other. The Mi-26's main rotor spans 105 feet. Its cargo cabin matches the internal dimensions of a medium tactical transport aircraft. Its maximum takeoff weight of 123,500 pounds exceeds that of a fully loaded C-130 Hercules, not comparable to a Hercules, heavier than one. That scale has a cost. On August 19, 2002, in Chechnya, a Mi-26 carrying 147 people, more than double its approved passenger capacity, was struck by a man-portable surface-to-air missile and came down in a minefield. 127 people died. It remains the deadliest accident in the history of helicopter aviation. The Mi-26 exists in a weight class no Western manufacturer has seriously attempted to enter, not for lack of engineering, but because very few countries have terrain that demands it. Russia does. What makes this Chinook different from any other? On the outside, not much. Same tandem rotors, same dimensions, same basic silhouette you'd recognize on any highway overpass or construction site. The difference is what's inside and what it's been asked to do. The MH-47G carries an aerial refueling probe, terrain-following radar, forward-looking infrared, and a navigation suite precise enough to fly hours at low altitude in complete darkness and arrive at a target within 30 seconds of the scheduled time, not as an aspiration, but as the operational tolerance. A crew that misses that window has failed the mission. The 160th Special Operations Aviation Regiment, the Night Stalkers, have held that standard continuously since 1981 through every significant American special operation of the last 4 decades. On May 2, 2011, when a stealth Black Hawk went down in the compound at Abbottabad, it was MH-47Gs from the 160th standing by that would have extracted every operator on the ground if the mission required it. Most of what this aircraft has done will never be reported. That's not a limitation of the historical record. That's the specification. The largest helicopter ever built by human hands sits in a museum outside Moscow and has never delivered a single pound of operational cargo. It lifted 40,200.5 kilograms to an altitude of 2,255 meters in August 1969, a record that has not been broken in the 57 years since. It had a rotor span of 67 meters. It could have carried 196 passengers in a two-class configuration. 4 records it set that year still stand today, and it was obsolete before the second prototype was finished. The V-12 was designed for one specific mission: transporting ballistic missiles and heavy military equipment to remote Soviet territory that roads couldn't reach. By the time the machine was ready, American spy satellites had mapped that territory from orbit, ICBMs had shrunk enough to move by truck, and the entire strategic logic that justified the V-12's existence had dissolved. The first test flight in June 1967 ended with engine vibrations shaking the control column, an uncommanded roll, and the landing gear slamming into the ground hard enough to burst the tires. Western press reported the project destroyed. Test pilot Vasily Koloshenko said flying it felt like sailing a large ship. Both things were true at once. The V-12 didn't fail. The world it was built for stopped existing first. The problem wasn't that the CH-53E was old. The problem was what 2 decades of sustained combat had done to it. 150 pounds of sand per airframe per mission, a fleet of 143 aircraft where 200 were mandated, 37% flyable on a good day. The Marine Corps needed a replacement, and what Sikorsky delivered was not an upgrade. The chief engineer said it plainly. There is not a single shared part number between the CH-53K and the aircraft it replaces. Same exterior silhouette, entirely different machine. 3 General Electric T408 engines, producing 7,500 shaft horsepower each. Main rotor blades with 12% more surface area than the E model. External load capacity of 27,000 pounds over 110 nautical miles in high altitude, high temperature conditions, nearly 3 times what the predecessor could manage on the same route. The program cost $15, $3 billion more than projected, and arrived years late. During flight testing, the tail rotor flex beam was delaminating in flight, a single point failure that could have taken down the entire power system. Someone reviewed that finding, calculated the risk, and decided to continue. The King Stallion isn't a story about American engineering confidence. It's a story about what it actually costs to fix something that was asked for too much for too long. The original Mi-26 flew for the first time in 1977. In the 49 years since, no Western manufacturer has produced a helicopter that matches its payload capacity of 20 metric tons. Not approached it. Not come within a meaningful margin. Matched it. The 20T-18 T2V variant didn't change that ceiling. It changed who sits inside while operating beneath it. The original required a crew of 5 pilots, a flight engineer, a navigator, a radio operator. The T2V does the same job with 2. A digital cockpit replaced 3 human roles without touching the airframe, the rotor system, or the cargo capacity. Same machine. Less than half the crew. The contrast that closes this entire list is straightforward. The United States spent $25 billion and 2 decades developing a replacement for a helicopter that was destroying itself one mission at a time. Russia took the helicopter it built in 1977, updated the cockpit, and kept flying. Neither approach is wrong. They're answers to different questions about what a military needs from a machine that has to work in places where nothing else can go. The next time you see a helicopter moving something that seems impossible to move, something that makes you stop and look up, there's a real chance you're watching a design that was finished before you were born, still waiting for the world to build something better.